All right, guys. Hey, welcome in. Obviously, I am not there today. I had to leave early. So here's your notes video for today to go along with the work that you're doing. The good thing is, a lot like yesterday, a lot of what we're doing is review today. It's kind of putting all these pieces together to find these values for slope for our rate of change, right? And today we're going to look at trying to find some answers here for different questions in different forms with those values that we have, okay? So we're looking at using an equation or writing an equation in slope-intercept form from a graph, okay, from a table, and from those points like we did the last couple days, finding our slope and writing the equation that way. All right, so we've got some things here that kind of take place and things that we can use to help us find those values, right? The important piece of this, though, is to remember that all of the things that we're doing are still leading to that same overall value, that slope, okay? That's what we're looking for. We're looking for slope. So ordered pairs, right? We're going to label those x1, y1, and x2, y2 when they give us two sets. That's going to be important when we use that to find our slope and then end up using our slope formula, right, to find those values right here, okay? And eventually we're going to get to an equation in slope-intercept form where we have an x and y value and an m value that represents our slope, right? And that b value that represents that y-intercept or where it crosses the y-axis. So I think today, after we go through these examples together and you do a little bit more practice with this, you'll really be able to kind of understand why all of this kind of relates to one another, how we can flow back and forth between different variations and different representations of finding and calculating slope or rate of change within these different formats. All right, guys, so we're going to start by writing an equation from a graph. So remember, we're going to get to a point where we can get y equals mx plus b plus or minus b. That last part could be a subtraction part, depending on where our y-intercept is, okay? And so when we look at writing an equation from a graph, here's the steps we're going to use to solve. The first thing is to identify the y-intercept. So we're going to begin with b. So remember, that is the point where our graph crosses the y-axis. Okay, so once we've identified that point, the next thing is to find our slope. Okay, remember, we can count the vertical change over the horizontal change. All of these things represent the same thing, right? Slope, or m, is the change in y over the change in x. So we're looking at that rise over run. We're thinking vertical change over horizontal change when we're graphing. So that's our second step when we have the graph to write our equation. And then once we do that, we can substitute our slope and our y-intercept into this form now that we know how to use it and answer these questions. So let's come down here and take a look. It says provide an equation for each line in slope-intercept form. So what I'm going to do is go ahead and write my slope-intercept form right underneath each one of these to remind me what I'm looking for. Okay. The good thing is we already have x and y coordinates, right? What we're trying to identify and what we're trying to find, remember, is that slope and that y-intercept, that slope and that y-intercept, okay? So here's the really good thing about this. If we begin with b, right, if we begin with our y-intercept, that's the point where it's going to cross the y-axis. So I'm going to go ahead and just highlight this y-axis in green here on both these graphs so you guys can see this. But this is where they want us to start. The reason they want us to start is because that's a good point that can help us then calculate our slope or our rate of change. So on this first graph right here is the point where it crosses the y-axis. Okay, so my y-intercept is at the point 0 when my x is 0, my y is -2. At 0, -2. So at the end of my equation, I'm going to have a -2 because my y-intercept is at -2. My b value is -2 since that is the point where it crosses the y-axis, okay? And then I'm going to come back up here and say, okay, in my second step, I need to calculate rate of change, which means I'm going to pick 2 points on the graph, right? And find that difference in my vertical change over my horizontal change, the change in y over the change in x. So vertical change going up and down over horizontal change going left and right. And this is a positive slope. We know that because it's going in that positive direction. So I'm going to count up how many spaces, which is up 2, and then to the right 1, 2, 3. Okay, 2, 3 would be my slope. So 2/3 is my slope. That's my m value, 2/3. So I'm going to write that down here. So my equation for this, right, any y value on this graph is going to be equal to 2/3 times that x value minus 2. So this is a lot easier, I think, for some of you guys probably visually to see, right, using the graph to find your slope and your your slope and your y-intercept, okay, and then looking at the graph, helping that step into writing your equation. All right, so why don't you pause the video, try this one on your own, this next one over here, all right, and then when you're done and you want to check your work, you can unpause the video. All right, guys, so hopefully you took a second to pause the video and try this on your own. All right, so remember, first thing we want to do, right, when we look at this one, is we want to decide where our y-intercept is. So on this graph, my y-intercept is at this point, this is where it crosses the y-axis. So at 0, 4, when my x is 0, I'm not moving left or right at all, and my y value is 4, that's where the y-intercept is. So if my y-intercept is a positive 4, in my equation, I'm going to add 4 at the end since it's positive. Over here, we were in a negative y-intercept, so that's why we subtracted. Here, I'm at a positive y-intercept. I'm above 0, so that's why it's a positive 4. And then you'll notice I kind of drew a couple different examples of how to find your slope. It looks like a point on the line right here. Since it's in a downward direction, I'm going down 1 over 1 each time to get to a new point. Down 1 over 1, okay? Down 1 over 1. Or if you even saw it this way, right? This bigger one, I went down 4 units and to the right 4 units, okay? So remember, down 4 over 4, if I did negative 4 over 4, that would be the same as saying down 1 over 1 is another way of looking at it. Down 1 over 1, down 1 over 1, right? So each of these points are going to give me the same overall rate of change. It may just look like a different value because of the distance I'm covering, but we always want to simplify when we're dealing with slope. So a negative 1 is my slope because it's going down and to the right, down and to the right. So all of my x values, as they get bigger, my y values decrease. So that's a negative slope. So I could write my equation like this. Y equals, whatever y I have on this graph, equals negative 1 times x and then plus 4. Or I could just say y equals negative x. I don't really need that 1 there because if there's just an x, we assume it's a 1, right? So negative x plus 4. So a couple different ways that we can write that. So visually, I think this is probably a little bit easier for some of you guys to see. And hopefully, you know, calculating the slope after you find the y-intercept then helps you fill in these pieces within your equation. Once you know these values, right, your b and your m, right, you can rewrite that equation where any y is going to be equal to your slope times x, your m times x, and then your plus or minus your y-intercept. All right, so now we're into writing an equation provided, or when a provided table of data is given to you, okay? So this looks a lot like what we did when we looked at our table, right? The first thing is to find that change in y or that change in x, okay? So remember, if you see a table that is vertical in columns like this is your x on the left side, y is on the right, okay? Nicely listed for us down here. If you ever do see a horizontal table, right, where it looks like it's more like rows, your x would be on top, your y would be on the bottom, and you'd have your values in that way, okay? So just keep that in mind. So when you're looking at for finding slope, you're finding the change in these y values on the, sorry, I made a mess there. Let me erase that, get rid of that, there we go. So remember, you're looking for that change in your y values on this side over your change in your x values on this side. Or looking at the y values changing down here over how the x values are changing each step of the way there, okay? Once you've done that, you're going to find the y-intercept. So you're going to look for that y-intercept value in your table when x is equal to 0. So remember, sometimes this is given to us. Other times we may need to use slope. We may need to use slope to find this. Okay, so sometimes it's given. Other times we may use the slope to find this within our table. All right. And then third, we're going to put it all together, right? Once we know the slope, once we know the y-intercept, to get those two values, you just plug them in, and then any y in this relationship is equal to that slope times an x value in this relationship, and then either plus or minus my y-intercept. So let's go take a look at this. It says provide the equation of the line here as we get going. So I'm going to go ahead and put y equals, leave a blank for m, x, and then leave a blank for b because we're going to do plus or minus. I'm going to go ahead and write that in both spots here, okay? Just so I remind myself, this is what I'm looking for, right? This is where I end up getting my final answer. So if we take a look at this first table right here, okay, Let me look at this. I'm looking for the change in y that's happening each time I get bigger. So from 1 to 4, that's a change of positive 3. From 4 to 7, another change of 3. 7 to 10 is another change of 3. And 10 to 13 is another change of 3. So that's really nice because it's going at the same rate, right? So if I'm thinking the change in y over the change in x for my slope is going to be equal to 3 over, if I go from -2 to -1, and then -1 to 0, 0 to 1, 1 to 2, I'm adding 1 each time, right? So this one actually ends up really, really nice. My slope is 3 over 1, or if I just want to simplify that, it's going to be 3, okay? So I'm going to plug that in as my slope, 3. Put it in my equation down here as well, okay? If I go back and I want to find the y-intercept in this next step, right, I'm looking for when my x is equal to, remember, when my x is equal to 0. Well, if I look at this table, I've already got a value there for my y-intercept, which is really nice. So this graph would cross the y-axis, right, at the point 0, 7. It's a positive 7, so I'm going to add that at the end of my equation, and then I've got my overall equation for this situation. Y is equal to 3x plus 7. I can always go back and check any of these answers, right? So -1 times 3 would be -3, plus 7 would be 4. 0 times 3, if I put a 0 in for x, would be 0, plus 7 is 7, right? And so then another one, if I did 1 in for x, 3 times 1 is 3, plus 7 would give me 10. 3 times 2, if x was 2, is 6. 6 plus 7 would give me 13 for my y value. So I know that I've done it right when I check it and go through it. The next one's kind of tricky. It doesn't look exactly the same. So as I'm going through here, I'm actually going lower in value. Yes, these numbers are getting bigger negative-wise, but that actually means lower in value, right? From -4 to -2, I'm taking 2 away. And from -2 to -8, excuse me, I'm taking 2 away, taking 2 away, taking 2 away, right? So that is my change in my values for y. I'm losing 2 each time. I'm going down 2 each time, okay, in my y values. And then my x values, the way that those are changing, I'm going from 1, 2 to 3 to 4 to 5. So that's pretty straightforward. You can see that you're adding 1 each time. So my slope for this one is actually -2 over 1, right? Or I can just say, since it was like this one over here, it's a fraction with a whole number, positive or negative, over 1. We just assume it's that whole number. And so my slope for this one is -2. So I'm going to go ahead and fill that in into my equation. My slope is y equals -2 times x. And then this one doesn't give me a value for 0, right? So let's think about this. Actually, if I kind of go backwards here, right, from here to here, if I add 1, 0 plus 1 would be 1. So I'm kind of going opposite direction. So if I take 1 away here, I need to add 2 over here, right? It's kind of the opposite direction, right? I would go from here to here by subtracting 2. So if I go the opposite direction, I'm doing the opposite operation, right? If I want to continue this pattern, each time I'm going down 2, so I need to actually go up 2, right? So I'm thinking to myself, what's -4 plus 2, or what -2 would give me -4? So my answer here is a -2. Because if I take -2 minus 2, I'm at -4. If I go the opposite direction, if I go -4 and I add 2, I would be at that value. So -2 is my b. So when my x is 0, my y would be -2. So that means at the end of my equation, when I'm writing it here, my y-intercept would be a -2. Okay. And so here's my equation for this. Any y value in this example is equal to a -2x and then -2. And I can always go back and check again, right? If I plug a 1 in for x, 1 times -2 is -2, and then -2 would give me -4. 2 in for x, -2 times a +2 is -4, -4 minus 2, -6. Do one more just for check. 3, -2 times 3 is -6. -6 minus 2 would be -8. So I can use my table, right, to help identify the slope, that rate of change, right, change in y over change in x. And once I've done that, I can either look for that value where it gives me an x of 0 to get my y-intercept, whatever that value is. And if I can't see it, I kind of need to follow that pattern to fill in my table. All right, guys, our last practice here is our favorite. Write the equation slope-intercept form given the 2 points. So this is one that we've definitely done the last couple days, and it's taken quite a bit of time to go through. It is the more difficult one just because of you want to make sure that you're doing these steps in the correct order, okay? And making sure that your values are in the right spots. So as we go through this one, right, we want to make sure that we go step by step. So we're going to calculate the slope first by taking y2 minus y1, the difference in your y values, over x2 minus x1, which is the difference in your x. And then you pick ordered pairs to use. Pick one of the ordered pairs to use. I always try to stay away from negatives, right? Told you guys this in class yesterday. Stay away from negatives when you can, right? It's not always going to be the case, but stay away from your negatives when you do that. And then this is the big step, right? You plug in an x, you plug in a y that you chose from your ordered pair, get the slope from the first step, and then you do that in your slope-intercept equation. So then you solve for b, right? That's where you're finding your y-intercept. And the very end, you plug in your m, you plug in b, and you rewrite the equation. So any y that you're looking for is equal to mx plus b. So let's go through our steps here for this one. So we do the first one here. And I'm telling you guys this because it's easy to make mistakes. Make sure that you label x1, y1, x2, y2, okay? That makes this first step a whole lot easier because you're going to take the difference in your y's when you take your second x, so in this case it's 12, right? This is calculating slope, right? Minus my first y, which is 9. I'm going to take that over 6, my second x, x2, minus, and I got to be careful here, my x1 is a -3, okay? So let's think about this. If we're on a graph and I'm looking at y units 12 and 9, so vertically 12 and 9, what's the change between 12 and 9? Well, that overall change is 3 units vertically right there, right, from 12 to 9. So that makes sense. And then as I get to this next one, remember, if we take away a negative, right, take away a negative, that's really like adding here. Because if you think about this, if I'm at a +6 all the way over here, and then I'm trying to get to a -3, so let's just draw that on the x-axis here, right? So this was a graph. You think about this is my y, this is my x. If I'm here, right, at +6, and I need to get over here to -3, right? I go back 1 to 5, right? Go back 2 to 4, back 3 to 3, back 2 to 2, back 1 to 1, okay? And then back 1 to 0. So there, and then -1, -2, -3. So I'm thinking 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total units, right? From a +6 to a -3 is a difference of 9 units, right? So that's why when I subtract the negative here, I'm finding the difference or the distance, and so I want it to be an overall value in terms of the distance that I'm covering between these 2 points. So subtracting a negative is really like adding because I'm finding that distance, which is a total of 9 units. But we don't want to leave it like that, right? We want to simplify as much as we can. 3 and 9 can both be divided by 3. So my most simplified version of my slope is 1/3 when I'm trying to answer this, okay? Second step, pick a point. So you got a -3 and a +9. That's an ordered pair, 6 and 12. Okay, we want to stay away from negatives. So I'm going to take 6 and 12 and use those as my x and y value when I plug it in here in just a minute to help me solve. Okay, so 6 and 12 is the point that I chose, kind of creeping away or staying away from those negatives, right? Step 3 is the one that can make you really get in trouble if you don't do it correctly. This is our form, remember, right? I know a value for y, and that's equal to the value I found for m, my slope, times the value for x that I came up with, right? This is a multiplication step. And then it's plus or minus that b. This is what I don't know. This is what I'm still going to be solving for in the 4th step. But I can plug in all of these other values. I already found my m in my first step, which was 1/3. So that goes right here, 1/3. Okay. I know my y value. I picked 12 as my y value. That's that ordered pair, right? So I've got a y value there. And then my x value is 6. Okay, is 6. So first step, found the slope, calculate the slope from the point. Second step, pick a point or an ordered pair that I can use for an x and y value. Third step is to plug it into that slope-intercept form. And then the 4th step is to solve for b. So as I'm looking at this and I'm answering these questions, right? When I'm answering this, I'm going to take 1/3 times 6. I know that much, right? So 1/3 times 6 is also like saying 6 divided by 3 because I'm dividing into thirds. So if I rewrite this, 12, my y value is equal to 1/3 times 6 is 2, and then it's plus or minus my y-intercept. So if I want to solve for b, right, if I'm trying to solve for b, 2 plus b would be equal to 12. Since this is smaller than that, I know that I need to add a positive value here. So I can think of it just by looking at it, doing the mental math, or I can say, okay, I need to take away 2. What's the difference here, right? To find that overall value that I'm adding. And so 10 is going to be equal to b. 10 would be my y-intercept on this one, okay? So the very last step then, number 5, right? It takes a little bit of time to do these, but it's important we go through all the steps. I'm going to rewrite the equation. Any y is going to be equal to my slope that I found in that first step, which was 1/3, times any x value. And then since my b value, my y-intercept is positive, I'm going to add 10 because it would start as a graph, right? It would start above the origin at 0, 10. And then I'd have a slope of 1/3, so up 1/3 every time that I move it, okay? So this does take a little bit of time, but it's a good practice. It's a good step. So go ahead and label this x1, y1, this one x2, and y2, and pause the video and try this last one here. All right, before we get too far here, I just wanted to set this up for you. Remember, it is so important you label these points, because if you're trying to find your slope, it's the change in y, y2 minus y1, over the change in x, x2 minus x1. That's the first step here, right? So my y2 is a -8, my y1 is a -4. So what's the difference between a -8 and a -4? If you subtract the negative, it's really like adding a positive. Because if you guys think about this, right? If I'm at -8 and I go up to -4, right? That's really a shorter distance than maybe some of us would think. If I'm down here at -8, I need to go up 1, 2, 3, 4 places, right? A -4 places in order to get that measurement, all right? And then if you think about your x change, right? If I'm at 0 and -4, 0 minus a -4, because when I do the difference, I'm finding distance. 0 minus a -4 is like adding, and I'm adding that together because from 0 to -4, if I'm going left to right, right? 0 to -4 would be moving to the left 4 units. So what is my overall slope here, right? I have a -4/4, which is the same as saying -1/1 when we simplify, or just simply -1 as an m value here for slope, okay? The next step, step 2, is just picking a point, okay? Can't really go away from negatives here, so I'll just pick the point that's got a 0 and only one negative, which is -8 for my x and for my y, okay? The third step, after we just pick our point, second step's pretty easy, right? Just pick that point. Third step, when I'm looking at it, is I plug this in, okay? So I have a y value, which was -8, and that's equal to my m value, my slope, which is -1, we said. So I'll go ahead and write that for now, times my x value that I came up with, which is 0, and then plus or minus b. We don't know what b is. That's what we're solving for, the y-intercept. So we're going to simplify and solve in the next step. So here's what I get in my next step. When I rewrite this, I get -8 is equal to -1 times 0. Well, anything times 0 is just going to give me 0, and then plus b. If I'm looking for b, what plus 0 would give me -8? Well, if I have nothing to add to it, right, just take away nothing, right? And so -8 is equal to my b value. That's what I'm looking for in terms of my y-intercept. So this one would cross the y-axis below the origin at 0, -8, when my x is 0, my y is -8. So then the final step, if you have your y-intercept and you have your slope from the very beginning, you can do step 5 and write your equation. So y is equal to, okay, kind of block this off right here. Y is equal to my slope, a -1, and I can write -1 if I want to, or just say -x, right? -1x, and then my y-intercept was a negative value, it's -8. So what does that mean? I would start the graph at 0, -8, and then I would go down 1/1, down 1/1, down to the right over 1, because that's my vertical change over my horizontal change. All right? One last note, good reminder here. The slope of a vertical line, right? The slope of a vertical line that you see, or sorry, horizontal line, excuse me, is going to be 0, okay? 0 is your slope for this. That vertical change is nothing. There's no vertical change that's happening. We're not going up or down at all. So remember, that's an example of y equals something. In this case, it looks like 1, 2, 3. Yep.
y equals 3 would be my equation for this line, because every point that's on this line, no matter where I'm at, is a y value of 3. Okay, no matter what my x is, no matter where I'm at on this line, my y values are going to be equal to 3. That's because there's no vertical change taking place, just a bunch of horizontal change, so my slope for that one's going to be 0. Okay, the opposite of that was when we have this vertical line here, right? So let's make this vertical line here. The horizontal change is nothing on this. There's no left to right change. But remember, we call this undefined, because if I look at an example like this, right, I'd be looking at 10 over 0, or a vertical change of -3 over 0, right, or even 200 over 0, right? There's no horizontal change taking place. So if you try to divide anything by nothing, you're going to get an error in your calculator. It's undefined. There's no value that we can give to it. So when the horizontal change is nothing, that's when we get that undefined, right? So in this case, this would be an x equals graph. And as we look at it, if we start at the origin, it looks like you go over 1, 2. Yep. So any point that's on this line is going to have the same x value, and it would be at 2. All right. Okay, guys, I hope this really helped you kind of go through stuff. I know it's a lot, but I just wanted to make sure that you went through the notes before you had your practice problems this weekend. Remember to work hard over the weekend, get this done, and be prepared, because on Tuesday next week, right before Thanksgiving break, is when we'll take our quiz. All right. Thanks for working hard, even though I wasn't there today. I appreciate that. You guys doing a good job with that. And let me know if you have any questions. Otherwise, we can talk over some things on Monday in class.